Hello, welcome to this lecture video. So today we will be talking about Kolmogorov-Smirnov distribution test. This is a non-parametric statistical test under test for one sample. So what is Kolmogorov-Smirnov distribution test? So the one sample Kolmogorov-Smirnov test procedure compares to observe cumulative distribution function for a variable with a specified theoretical distribution, which may be normal, uniform, Poisson, or exponential. So given a data, of course, you can test if the data follows a normal distribution, uniform distribution, Poisson distribution, or exponential distribution using Kolmogorov-Smirnov test. So this test is commonly used whenever we want to know if our data is normally distributed or not, simply because one of the requirements for us to use a parametric test is for us to check if our data is normally distributed or not. So in this video, we are going to generate one particular value or consider rather one example using Kolmogorov-Smirnov distribution test. So let us now go to our data set. So let's move to our data set. So this is our data set. So of course, we know that by central limit theorem, if the number of sample size is at least 30, we can already conclude that the data is normally distributed. But for the case of our sample, the sample size is less than 30. So which means before we will be able to know what specific test to use, we need first to check if our data is normally distributed or not. And we can do that using Kolmogorov-Smirnov test. So how to do that? So we will be checking if our pretest data and post-test data are normally distributed. We have to click Analyzed, Non-Parametric Test, and of course, we have to go to one sample KS, this one. One sample KS. So let us click that. So if we click that, we have here the different test distribution mentioned in our introduction of the test. So we can actually determine whether our data is normally distributed, uniformly distributed, exponentially distributed, or if it's a Poisson distribution. Okay, so let's consider these two data, the pretest and the post-test at the same time. So you can do it one at a time, or you can actually generate it for both the pretest and post-test. So all we need to do is, after of course transferring it into our variable box or test variable list, we can now click OK. So this is now the result of one sample Kolmogorov-Smirnov test. Now, what we need to see here are the values of asymptotic significance, or the p-values. So the p-values here are our basis whether our data is normally distributed or not. And based from the data, since our HO here states that the data is normal, our HA indicates that the data is not normal. We know that we are accepting our HO if P is greater than or equal to 0.05. So if P is less than 0.05, so indicating that the level of significance is 5%, we are going to reject our HO. So here we accept our HO. So let's go back to our data. So 0.420 means that P is greater than 0.05. So we accept HO. The data is normally distributed. Similarly, for our data 0.931, this is also greater than 0.05. So we accept our HO. Therefore, the data are normal. So we are now sure that the data are normally distributed. So both pre-test and post-test are normally distributed. So you can now proceed in the other steps that you need to do, because usually this is just the preliminary analysis before we can move to the appropriate statistical test that we're going to use, whether it is parametric or non-parametric. So this ends the video. Thank you for watching.